this tutorial, we'll build a simple distance sensor using an Arduino. This project introduces you to RGB LEDs, resistors, and Arduino programming. You'll learn step by step how to wire the components in Tinkercad circuits, and write basic code to make the distance sensor. First, open Tinkercad in your browser and log into your account. On the Tinkercad dashboard, click the blue Create icon at the top right, then choose Circuits. This opens up a new Tinkercad workspace, where you'll build your distance sensor circuit. Click the project name bar at the top left and rename it to Distance Sensor. On the right-hand side of your workspace, you'll see the Components panel. Make sure to choose All from the Components bar rather than Basics so you can access to all the components. In the search bar there, type Arduino UNO R3. When it shows up in the results, click and drag it into the workspace. Now, rotate it to match your preferred layout. In the toolbar above, you'll see the rotate buttons. Click the rotate button 3 times, or press Ctrl plus R 3 times. This will make wiring easier and keep the circuit neat. For better visibility, you can zoom in and out of the workspace using your mouse scroll wheel. Next, in the same search bar, type Breadboard Small. Drag the Breadboard Small into your workspace. Rotate it 3 times as well. Along the sides of the breadboard, you'll notice 2 long rails. The red rail marked with a plus sign is your power rail, and the black one with a minus sign is your ground rail. These distribute power across your circuit. Place the breadboard beside the Arduino so that connections remain short and tidy. Now it's time to power the breadboard. Let's pick some jumper wires. Click on the Arduino's 5V pin on the left side of the board. When you click a pin, Tinkercad automatically activates the wire tool. Drag a wire from the 5V pin over to the positive power rail, marked with a plus sign, on your breadboard. Once the wire is placed, click the small colored square on the wire to open the color palette, then select red for easy identification. While any color works electrically, it's best practice to use red for power, black for ground, and different colors for other connections to keep circuits organized and easy to understand. Then connect the GND pin from the Arduino to the ground power rail of the breadboard using a black wire. You can either draw the wire first and then change its color, or select the color before drawing. Both methods work fine. These rails now distribute power to all components. Now, we'll connect the Arduino's digital pins to the breadboard. Connect digital pin D3 on the Arduino to breadboard hole J25 with a pink wire. Connect pin D5 to J23 with a green wire. Connect pin D6 to J22 with a blue wire. Connect pin D11 to E4 with an orange wire. You can adjust the shape of a jumper wire by clicking and dragging its corners. This helps you keep your circuit layout neat and organized. Connect pin D12 to E5 with a purple wire. Let's make sure our components get power. Connect D3 to the power rail using a red wire. Connect D6 to the ground rail using a black wire. Finally, connect D24 to the ground rail using a black wire. This completes the key wiring for this section of your circuit. Now for the star of the show, the RGB LED. An RGB LED is actually 3 tiny LEDs, red, green, and blue, all packed into a single LED housing. Go back to the Components panel, search RGB LED, and drag it into the workspace. By default, the pinout is set to RCBG. Change that to RCGB. Place the RGB LED on the breadboard. It is a common cathode LED, so the second pin from the left is the ground. The pins from left to right are red, ground, green, blue. Rotate it to match the layout, then carefully place it on the breadboard with red leg in A25, cathode, G&D, in A24, green leg in A23 and blue leg in A22. This sets up your RGB LED for proper color control in your circuit. Next, search for resistor and drag it in. It will default to 1 k ohms. Click on the resistor, then change the resistance value to 330 ohms. Rotate it 3 times and place it between G22 and E22 for blue pin. Since we need 2 more resistors, you can either copy and paste the 330 ohm resistor or search in for another resistor in the component panel. Place one resistor between G23 and E23 for green pin and another between G25 and E25 for red pin. Now, search for the ultrasonic distance sensor in the components list. You'll see 2 ultrasonic sensors appear in Tinkercad, the HCSR04 and the ping sensor. For this project, we will use the HCSR04. This sensor will help our circuit measure how far objects are by using sound waves, just like a bat. Drag the ultrasonic distance sensor to the workspace and rotate it 3 times to align it with the breadboard layout. Carefully place the sensor so its pins fit into the breadboard rows. Position the sensor for easy wiring, placing its pins on the breadboard so that VCC pin goes into A3, trigPin into A4, echoPin into A5, and G&D pin into A6. Ensure all sensor pins are properly seated in the correct breadboard rows, so that the VCC pin of the ultrasonic distance sensor is connected to the Arduino 5V pin, the trigPin is connected to digital pin D11, the echoPin is connected to digital pin D12, and the G&D pin is connected to the Arduino G&D. Circuit setup is now complete. Let's programming the Arduino. At the top right corner of your screen, click the code button. By default, it opens in block code mode. Change to text mode by clicking the drop-down in the top left of the code window. Delete the starter code inside. Next, start typing the code for our distance sensor circuit. Define pins for ultrasonic sensor trigger and echo. Define pins for red, green, and blue LEDs in the RGB LED. Create a variable to store the measured distance. Start the serial connection in setup at 9600 baud. Set the ultrasonic trigger pin as output. Set the ultrasonic echo pin as input. Set the RGB LED pins as outputs. Inside the loop, get the distance measured by the sensor. Print the distance reading to the serial monitor, followed by units. If the object is closer than or equal to 10 centimeters, turn the LED red. If the object is between 10 and 20 centimeters, turn the LED yellow. If the object is farther than 20 centimeters, turn the LED green. Wait 50 milliseconds before checking distance again. The getDistance function sends a trigger pulse and measures the pulse return. Calculate the actual distance using echo time and return it. Let's run the simulation. Now, go to the top of the screen and click Start Simulation. If there are errors in the code, it will show up on the screen after clicking Start Simulation. Just check the message and fix the issue and start simulation again. In Tinkercad, you can interact with the ultrasonic sensor by clicking on the sensor icon. A green dot will appear. This represents an object. You can slide the dot to simulate the object moving closer or farther away from the sensor. As the object moves, the distance is measured in real time and shown in the serial monitor. Based on how close the object is, the RGB LED will change color. If the distance is less than 10 inches, the RGB LED turns red. If it's between 10 and 20 inches, the LED turns yellow. For anything beyond that, the LED glows green. When you're done testing the circuit, click Stop Simulation to end the code execution. Congratulations, you've just built your own distance sensor circuit inside Tinkercad, combining Arduino, sensors, and RGB color mixing.